This receiver I have here is about 10 years old, maybe 11 now. It is an, see if I can get it, an Onkyo HT-R667. So the issue I had with this is I turned it on and it started going into protected standby mode. So I hopped on the internet, did a little research, and everything I found pointed to one of these 7 channels. This is 7.1 Dolby surround sound system. So everything pointed to one of these channels being shorted. This chip right here is a temperature sensor, and when it reads a high temperature, and I'm sure there's probably some in circuit, but I didn't really get that deep into it, where it senses current, and if it's a short situation it throws it in the protected standby mode. But I started here. I plugged it in. I own one of these, an infrared thermometer. Plug it in, turn it on, and it clicks into protective standby mode. So I just kind of started going around here, see where it's hot, because if you get a short, it's going to get hot real fast. Coming down these transistors, I hit this one and it was 180 degrees Fahrenheit. This one was 230, and then it dropped back down to 70, 70, 70, all the way down. Everything else was cool, nothing else was hot. So I knew this was the channel that had shorted out. And also on this Onkyo, the HDMI board here, these inputs stopped working several years ago. I just never really bothered. I just connected directly to the TV and continue with life. I didn't troubleshoot it at all at that point. I got the service manual for this model and just started going through the components. And I've kind of marked them on here in red on what I found to be bad. So I found some fuses that were blown. And this is a surround back left channel. There was a transistor in between these two transistors that was blown. It was actually physically cracked through the center of it. And you can't see these kind of things until you actually pull it off the board. And then this is a 100 ohm resistor that was way outside of bounds. And then those 2 other transistors down here that were also dead faulted. And that was everything that I found to be broken on the main board itself. Then I went to looking at the HDMI board. The HDMI board, usually there's an issue with people having this DSP chip getting too hot and reflowing and losing its connection. I don't have that issue on mine, but what I did have was some bad capacitors in those. Mainly there's 5 that you can replace. There's one on the top. That guy is right here. This is the one I put on, and there are 4 more on the underside of this board. Went ahead and replaced those and got this thing working again. Oh, one thing to note is when you work on this kind of stuff, this is where you need to be extra careful, because you're talking about high voltage AC. Most of this stuff over here is low voltage DC, so you're not gonna really have a risk of damaging any of your equipment, you know, like a multimeter. But here you can definitely get a healthy shock. And also you need to be careful when disconnecting connectors. This connection didn't want to come apart and it ended up breaking. I had to solder some wires in, and I wanted to keep the quick disconnect, so I had to go find a place that sold some quick disconnects, and that was apparently the smallest I could find in Kansas City. So let me pause this and I will throw this in front of a TV. I've hooked it up, plugged it in, and got HDMI running from Western Digital Box, and running out to this TV. Everything is working fine. Sound is good. I haven't checked all the channels yet, but I assume they're all going to be good. So we got good. HDMI shows up. Good, good, good. It's good repair. So now let's look at the parts, right? So these were the bad parts. Here's my 5 capacitors, 2 fuses, transistor, resistor, 2 other transistors. So I'll connect some leads. What does it look like when one of these doesn't move? NPN or PNP transistors go bad? Let's see. Let's go ahead and throw my multimeter into diode test mode. So from base here, we got open line. Again, open line. All right, so we got a reading now. So this only goes one way. So you can't switch it around and get a reading. So at least that's the direction. And at least learning about these and testing, I had to draw it out when I was doing my testing on the board itself of what my expected readings would be, so I could just quickly see. And then again, more readings on different parts, just writing it out so that I could see exactly what's good, what's bad. So let's look at one of my faulty ones. Nothing there. Nothing there. Hear that difference? That is a dead fault right there. That is wide open. Current flowing straight on through that. So, high heat. And I think this one is wide open as well. Yeah, wide open. Definitely not good. So what does a good resistor look like? Switch it over to ohms. Here is half watt ohm resistor. Should be within 5%. Reading 98.2 ohms. Good, right? Here's what a bad one looks like. Get this on there. .36. Not good. That was really the only one I found that was way outside of range. I didn't see any capacitors blown. These were the capacitors for the HDMI board, and pretty easy to see that the fuses are blown as well. Other than time, let's look at the part list, right? How much money did this cost? For this little transistor here, that was $1.04. I already had 100 ohm resistor, so that was free. Picked up a set of 4 fuses from Radio Shack for $1.56, so I really only used 78 cents in this. These are the capacitors here. I ended up buying 10, but only needed 5. I only used $1.17 worth of those. So these are the real expensive ones, and I bought extras just in case I damage one or another one of these blows. So 313 and 323, and then 578 for another 5-pin connector because I damaged one. So I was in for $15.13 to fix that. Not bad.